Hello, one and all, to Codeweaver Writes Code. It looks like my audio is working fairly well here. And yeah, I'm getting right back into my Rust coding. So to set the stage for this, hopefully my voice is coming through okay here. Yeah, I think so. Always worried about that. To set the stage here, the briefest possible recap, because you can go back and see the recaps in the first two parts. We're going to switch straight over to this. This is the recap. You can pause the stream and take a look at it yourself, either before or after. Basically, the idea is that I have a particular kind of zipping operation where I take two streams or iterators or whatever you want to call them, and basically zip them together, but where I can process each of the lists at different rates. And the reason why this came up is because I noticed that I was doing something similar for the merge part of a merge sort as compared to the find two values in a list that added to some target value, which was part of the Advent 2020 first little puzzle challenge. Neither of those are individually hard to write. Obviously, I took a crack at them sort of the ordinary way, and now I want to try to do it by way of creating a higher order function, kind of like zip. So, to very quickly touch base on the kinds of languages I'll be using, I've already done a Haskell version, a C++ version, and a C# version in mostly idiomatic style. For example, in C++, I use standard containers in a strict sense. I'm not using C++ 20 ranges. I probably should, but I haven't gotten there yet. Maybe I'll do that later. And in C#, I just wrote my own link expression, so it operates just like any other link expression. And on the Haskell side, I, of course, use its idiomatic lists as iterators, which, so I'm not going to show you all that code because I've done that in the previous streams. But what I will do is I will close off my intro because nobody needs to see that. This is effectively what the Haskell version of this looks like. That's more or less it in total. And the idea here is that as I step through each of the lists, and I pass off elements from those lists off to a function, which then returns how to combine them and how to step the lists. There are various things that I've considered to improve this. For example, if I tell the thing to arbitrarily halt, I have a dummy entry that I have to then later filter out. But I decided to write it this way because it does allow sort of a filter stage built into this thing, and I decided to leave it in there. The only thing other than that fusion function I need to provide is what to do on the tails of lists when one list runs out before the other. And so there are functions to do those individually. This works quite delightfully. I like it. It's compact, and it's pretty, and it runs pretty well. And so I modeled the C++ and C# versions more or less off of this. And they're quite a bit wordier than this, but they work more or less the same way. I'm going to try to do this in Rust because I'm learning Rust. That's why I have started up this series. I feel like it's going to motivate me to try to sort of push hard on some of these problems if I'm doing it with everyone else. So I've had some fantastic people sort of show up on stream to help me out. I'm not sure if they're going to show up this evening because this is not my normal broadcasting time. So here we go. I'm going to try to replicate this function, and I'm going to try to do it with Rust. So let's see if we can get on with doing that. So we are not going to need this anymore. One of the other things that, do I want to save the modified items? I'll just hide this window because I may want to look at it later, but hang on a second. Programmer's Notepad going away. I'm now also using Visual Studio Code for a couple of reasons. Because I had it recommended to me as a not half bad IDE to poke around with. I'm going to have to, however, I think, not adjust that. I'm going to have to adjust one of my window sizes just to get it not overlapping quite as badly as that. What are we doing here? Actually, I probably don't need to. No, I think we're good. I think we are, in fact, good. Yeah, that's fine. Okay, sorry about that. Still working the bugs out of my presentation. So I'm using Visual Studio Code because I had it recommended to me. It was kind of odd to set up because it's not really, like, it's a sort of a Microsoft's attempt at a universal lightweight IDE shell from which you then have to plug in a bunch of stuff to build up your tool chain. I'm not used to it. I'm more used to Visual Studio, but this seems to work pretty well. I'm going to give this a go. Taking a look at the stream, I'm going to see if I can I just make the text just a little bit bigger. Appearance, zoom in. Let's see if we can. Think that might be a little bit better. A bit more readable on stream. Right. So here is my attempt at doing an ordinary zip function in Rust, which I've been working over the last couple of days. In fact, a zip with, because I'm going to need to have that combining operation. So I've basically been learning the various mechanics of the type inference system and the various uses of traits and the like. Now, fortunately, I haven't had to fight with the borrow checker all that much. But basically, it's my test harness, or at least as it's developing. I'm going to add a few more cases to this once I get the merge zip with up and running. But the basic idea here is that I'm basically starting to base my zip operations on my zip widths, and then I will base my zip widths on my merge zip widths because it is strictly a superset of behavior. Right. So, for example, here was my original zip, and now the zip operation basically fobs this off on my custom zip width. So I'm ultimately going to have code that looks a lot like zip width in order to do the merge zip width, just with a few extra functions. Let's see if we can do this. So, a couple of things we're going to need. So, this is our stateful iterator that internally maintains the two other iterators it needs to do its work. And what I need to do is store the two iterators that are ultimately mutable. And actually, they are not necessarily... They have to be mutable, but they are also owned by this, because once they're passed in here, I believe I am allowing them to be consumed. So the function type here is to be able to store the mapping between the mapping of two items that come from two different iterators, which do not need to be the same type, and they produce a third type, which is technically a tuple. Well, in the zip operation, it's a tuple of the first two, but arbitrarily it could be any combined value, so I have to pass that in separately. Now, technically, and I figured out a way to round this. This value is technically deducible out of the function and the two iterator items, but I don't have a way to deduce that at present, so I have to pass it in independently. That's fine. So for my merge zip width, and I'm going to get rid of the my because there is no standard zip merge zip. So this is going to be a merge zip width. I'm going to need my two iterators just like before. I'm actually going to need two function types. Actually, technically, I'm going to need three function types. One of which I'm going to call, what did I call it in the Haskell side? I may occasionally refer to the Haskell code in the background here, which you can't see. I called it F2. I could have called it F, X's, and Y's, but I'm just going to call it F2. So that's F2, which combines the two of them. I need a function that can take the X's and produce something if we want. A function on X's, which should produce, see, how do I want to do this? This is going to have to be a function that itself can that itself is an can take each of the elements of the x's and produce the output value for this entire function because I don't have the y's. Here's an interesting thing. In the Haskell version of this, all I had to do was effectively pass out a list tail that was processed using the function. So I just basically did a map operation, which I can, you know what, I'm going to turn that back on just to show you. So as you can see here, when I ran out of values, this is just pattern matching, which a version of which we can use in Rust. There's a pattern matching basically on a list, which is more or less a pattern matching on an iterator. I don't have to do any guard tests or anything like that. And in this case, when I run out of one list, or I run out of the other list, I use the appropriate function, which is basically a map over those items in order to be able to produce the resulting tail on only x's. And that might just as easily return a completely empty list. Yeah. And so with the y's as well, but I don't think I can do this here. I think what I need to do is, because the iterator type and the container type are not synonymous like they are in Haskell, I'm going to have to do something similar to what I did in C#, which is to iterate on the tails independently at the tail end of everything. So you know what? Let's, I'm going to quickly pop open my C# version of this, which I can probably, you know what, it's probably just easier if I pop that open in VS Code. If I can find out where I put it. Give me a moment. Although I could just open it up in Visual Studio and show you all. Except that just means one more application to stream. Taking glorious seconds in order to open that up. The closest approximation, because of the lazy iterators, is the C# version and not the C++ version. So I think I will go with that. I'm still showing the programmer's notepad stuff. So I will come back and return to that later on as I see fit as a comparison. But probably what I really want to do is something closer to... All right, let's see if I can pull this up in... All right, closing that app. Pulling open Visual Code, doing an open, blank, and there's my C# code. Do you want to trust the authors of this file? Yes, that's fine. I'm not going to be running this. So, ignoring all the math abstractions and a bunch of other support stuff I had to write, this is the way this actually looks. And in this case, what I did was I processed the main part of the list, and then I processed the tails individually, but still lazily, because I couldn't, as I was processing individual items, I couldn't just say, and take the rest of this list and just tack it on the end like I could in Haskell. And at least I couldn't find a sensible way of doing that. Maybe I can discover one. But you know what? More than one way to skin a cat, so I'll probably do something a little closer to this. All right. So, going back to the Rust version of this. So, I need my my standard f of x is going to take an individual item. Is that what I called it over on the C# version? Very quickly looking, I called it. Actually called it f of x's and f of y's. How did I actually end up using it? I'm pretty sure I did them one at a time. Yes, I just called it f of x's, and I should have really just called it f of x. So yeah, I'm going to change my naming convention because that's not great. So I'm going to call this as a type f of x, call this type f of y, and I'm going to call the actual, alright, so that's going to be f of x, we're going to need f of y here. We're also going to need those new types here. So it's going to be f2 is a function that takes both and produces a c. F of x is going to be a function which takes only the a side, and I probably should have called it x and y instead of a and b, so let's actually start fixing this up as we go, because we're being ridiculous. So this is going to be called x's, and that's going to be called y's. And yes, I do have certain Haskellisms in my repertoire because I learned that long before Rust, and so deal. So this is actually, yeah, hang on, x, y, y's items, x's items. I'm gonna need some commas in here. F of y. Yeah. Incidentally, if anybody stops off as a viewer, feel free to pop in and touch base. Or don't. I'm doing this mostly for myself, and I hope that some people will pop in and comment as they like. So y's item. Okay, so that covers. Oh yes, and I have to have. So this is going to be f2. Which is this. But I'm also, oops. This struct also needs a state of f for the tails. Sorry, f of x, which is of type f of x. That'll do. And of course f of y, which is going to be f of y. Now this is the entire state, the iterator's state, that is necessary to perform this operation in iterator form, I believe. Getting some local fun sirens happening outside. Sorry about that. Can't filter that out when I'm doing this live. So this is f of x and f of y. Got to keep the capitalization right. So let's clone most of this, actually. All of these types are the same ones as I'm going to need to do here. Actually, the return type, instead of calling it C, I'm going to call it R. Right. Actually, I need all of that, so I didn't need to make that edit, but here we go. Doink, there we go, and this is R. Could not find X's in this scope because I forgot to change these guys, so that's fine. Right, so this is implementing the iterator trait for this state glob such that I can produce, this should be merge zip with, it has to be R as well. I'm not sure I like some of the way Rust does it. I thought I had format on save turned on. I apparently don't have that on this project. Oh well, I will turn that on at some point. I have to have an associated type buried in here because I want to be able to refer to R from outside the iterator. Actually, the iterator system needs to refer to R outside the iterator. It's like having a type alias and embedded type inside of, C++ templates, for example. Very common technique. Here we go. Now, the behavior of the next part of this is actually very similar to the behavior of my zipper, because what I'm doing here is I'm basically saying when I get the next call for next, which is how the iterators work, a little bit like C-sharp's iterators, for example. It calls next, and basically I have to try to produce an option which contains the item in question. Okay. So, I actually don't need to, hang on a second, I gotta get my brain wrapped around this. This is just for the next operation, but I need to be able to construct these using my, so it's going to be merge zip with. And this little trick here is how we make it compatible with the rest of the iterator system. And let me see if I can remember how this works. This is going to be merge zip withable. Going to get this part out of the way so that I can focus specifically on the implementation. So the way this works is we have to have more types for one thing. So we have to make it so that effectively we can have the iterator on the left hand side of a dot my merge zip or whatever it is that we're going to do. And then have the second iterator as its only parameter so that it can be done in this daisy chain style. So we can just daisy chain one iterator into the next. In order to do that, for the zip case, what we had to do was we wanted to implement basically we wanted to implement a function that could take self as the first parameter and the other iterator as the second parameter, as if it were a function of let me see, how did I do this? So that it was a function that was applicable to all iterators, but you can't do that on abstractly all iterators by, I don't know, I don't think I can. I would be able to by specifying each individual iterator. I wanted to do it on all kinds of iterators. So I had to say that I was implementing a trait that was my zippable for objects that had the trait iterator. I had to do this by way of traits because I couldn't implement it directly on the underlying structure, which is fine. But what that means is, or what that meant here is, I have to define the trait, define the way the function actually works, and then implement for that trait in order to fill it in for iterators. There's no mention of no mention of the left-hand side iterator. So there's no code specified up here for the trait, because I guess you don't do that. You don't have default implementations. At least I haven't started experimenting with whether or not that's true. I had to implement it as a separate trait here, and that was the way to get it to apply to all kinds of iterators. And so I'm gonna have to really remember how to do this. Traits are a lot like Haskell type classes. So this does actually make a lot of sense to me. I want to be able to say that I want to be able to call a function that is applicable to any kind of object that happens to implement this trait. It can be anything in the world. I just want it to implement that trait. If it does, then it satisfies the constraints that I have to place on when I want this to be callable. All right. And the reason for that is because I'm going to be using iterator operations. Right, so in order to mimic that, I have to do this is merge zip withable. The signature isn't quite correct. And this is going to be constructing. Ultimately, what we need to be able to do is construct. I do not want to install the recommended extensions right now. Thank you. You can show it again, just not right now. I might bring my C# and C++ projects in here. Actually, because a lot of my stuff is going to end up being console related anyway. Right. Where were we? Right. We need this entire complicated signature again. There's a lot of boilerplate in this for types, I'm noticing. Need to find a way to reduce this eventually, maybe. So this is the trait. One of the types I don't need to. Oh yeah, one of the types is the. In order to implement it as a callable with a self on the left, is it needs to be templated on A iterator. I can defer having to need to know B iterator until the actual function, which is why that's put in here. So this is actually X's. This is Y's. I now need to build up the iterator structure. This is the one without code. This is just specifying what the function is that I expect all merge zip withable traits to behave with, and this is going to be f2, f of x's, or f of x, f of y. And actually R, because I'm doing R for return type. The parameters passed in are going to be self, which is going to be the iterator on the left. Is going to be y's. F2 is going to be F2. F of x is going to be f of x. F of y is going to be f of y. Have I got all of the parameters necessary to go in? Yes, that's what I'm going to be passing in. Okay. So that specifies the interface, as it were. Whoops. I have some where clauses to sort out here, and that's actually this. It's going to be this and this as per these other functions. So that's pretty much exactly that. This is y's, which is an iterator. Whew. Rush. Okay. Now, having defined that trait, I now need to implement it for any A that is itself an iterator. So there we go. We are, of course, missing all of these. Yeah, and this is now x's, and this is also x's, where x's is an iterator. This is going to be a lot of fun figuring out all the ways I can get traits to interact with one another as this series goes on, or future series goes on. So wise, what am I missing from wise? Because I didn't call it wise here. That's why. And obviously here. And here. Right. Now, given all of this, this should actually compile. It just won't do what it's supposed to, because it'll actually attempt to do an ordinary zip. And actually, I have to define my f2, f of x, and f of y slightly differently. Like, this is not actually syntactically correct. All of these should produce the same thing, but what it's actually going to produce... okay, so here's what it's going to actually produce. Let's figure this out. So this is fine because I'm going to define what R is. That's basically passed in as one of the parameters. So this structure is defined adequately. What I would like to be able to do actually is specify that this returns... because I don't know I'm producing a tuple. That's the problem. Because I don't know that I'm producing a tuple, I can't actually state what R is here, which is unfortunate. And actually, I can't state it here either for similar reasons, because by the time I have the actual function, a variable of the actual function type, this is just an implemented function, so I don't know any more about R there than I do in here. I just have to assume that R is compatible. I can't deduce it. And in these functions, by the time that I know what the function is, it's too late to... No, this is where I automatically deduce what R is, because R gets captured by its... hopefully, in terms of return type deduction, it's captured by its use as a parameter here. So if this is F2, so hang on, let me see if I gotta capture this. Just clone that. Yes. By the time I'm inside this function, I passed this in. F2 is asked to be constrained to this type, and the minute that happens, R is bound to the return type of the function in question, which is why I don't need to specify actually any of these parameters when calling this method. One would hope it is deduced, but when I'm constructing these, I have to specify them because I can't deduce them any other way. At least not that I found out yet. Haha. Maybe there is a way. I don't think so though. All right. So that makes setting up the state object a little tricky, but that's okay. The only thing, so what I'm going to do actually is, okay, so, and actually R is supposed to be the item type, so this isn't quite right. This function isn't supposed to produce an R like the zip. It's actually supposed to return basically a, what I called in the Haskell side, actually, or in the C# side, so let's poke our noses over here. I have an enum which basically outlines the action that I want to take. Now, anybody who is taking a look at this code later and saying, hey, look, you could just combine this action with to say advancing both means that I'm still only emitting one value. Left, I'm emitting one value. Right, I'm emitting one value. And halt, I want to emit no values. And I could set this up as basically an enum with associated values. I can't remember what that's called in Rust, and I'm going to be looking it up shortly because I'm going to need it in a second. But I could actually set this up as a data type that contains that optionally for some of these contain additional data. And that's that would work really well in Haskell. I've used that kind of thing in Haskell all the time. Things like the option class, for example, in C# and in this, actually not so much in C#. Well, whatever. The data types in Haskell allow this sort of thing because they have basically enums are just named constructors with any kinds of associated data you want. So I'm very familiar with that. The reason I didn't do it here is because it's a little harder to do in C++, and I wanted all these things to have a very similar operation. And more to the point, it turns out that by implementing it this way, because I have to filter, I get filtering essentially for free. By filtering, I mean if I ever emit a halt, I don't have a value that I can emit into the output stream. And that's just a design choice I made. So what I'm going to do is I'm going to need effectively this enum over on my side here. And it's actually going to be... I just pasted that in for naming, equivalence. So what I need to look up now, and this is why I have the Rust docs section open, I believe, I haven't been covered up by the advent of code because I was showing that earlier for the sake of anybody who wanted to look at the sum to end thing, a part of which that was the basis of this puzzle. So going into OBS again, let's close the advent of code stuff, and there's the Rust documentation. And what I really need is enumerations. And this knew that I'm doing that I don't know how to do these enumerations early. Hey, look at that. There's the result. There's an example of the kind of thing I'm talking about. Because this more or less looks like, an enumeration with associated data. So enumerations. Enums and pattern matching. Let's see if we can figure out how to do this. Enum values. Yeah, so here we go. It's this sort of thing that I'm after. Right. You can do this in Haskell. You can not yet do this in C++. But I think you can do it in C#. Doesn't matter. I didn't end up using this. So I'm only really going to end up using enums for the sake of enums in this. But altering this to do this in a smarter way is left as an exercise. I know how to do this sort of thing. I'm just not going to. So the enumeration is going to be just this. I guess I technically, because it's not a statement, I guess I technically don't need the closing semicolon. So there's my enumeration. And to just go along simply with the rest of the standard design, what I'm going to say is that this actually returns a MZW step and a value which may or may not be there. This is one of the inefficiencies I'm mentioning where, I'm basically listing out the item separately and it has its own optionality associated with it. There's probably some sort of performance hit there, a minor one. Right. So what do I want here? It's not option, it's result, I think, because it's not an error, it's a result that may or may not be there, right? So this is actually going to be a result of R. Yeah, that's pretty much exactly what I want. Because I want R to be deduced on the thing that I actually want to return. I don't want R to be this whole thing that I've got selected here. So let's just tool this up. All of the functions have to return this, except actually these don't, because once I'm down to individual lists, when one of the lists is run out, I don't have to advance one list or the other or both or halt. All I'm really doing is outputting, are there any more elements? And how did I actually code this up? I basically said in the tail end, actually in this case, interesting. I actually had f of x's and f of y's in the C# version, which has an iterator kind of similar to Rust's. I actually had it take the entire tail and presumably effectively return an iterator that I could then just iterate out and spit values. I didn't actually have to process these one at a time. I'm going to go with that because of the very similar nature of the iterators. Okay, so that changes my function definition slightly, but not the... okay, so in the case of... Okay, let me figure this out. This one definitely has to return this type. Fine. This one actually returns... Oh... I need an iterator. Am I going to be able to do this? I need to be able to, if I actually take in the entire, if I take in an entire x's, what I need to be able to do is return an iterator that, an iterator where the item is that is in question is of an iterator that is of type an iterator. I need an abstract iterator of any kind that has as its item one of the R's, because then at that point I don't have to depend on me to iterate through. I still have to iterate through the rest of the items, but I can do it just basically until the iterator runs out. It's not like tacking on a tail list on the end of a list that I'm iterating through in Haskell. And I don't want to call f of x's individually because it may be that may not be. I could do it that way. It would be a very C++ way of doing it. Because that's how I had to do it in C++. Okay. It needs to be... So f of x, f of... Okay. The reason I need to have the functions passed in as generics is because I think if I'm using lambdas and the like, they all have unique types. I can't get away with can I get away with building up an abstract function that, or just a function that takes, no, because if the function takes generic types, I don't know enough about how to do that. I'm gonna have to solve that later. I think what I'm gonna have to do is I'm gonna have to say x it's an iterator that is going to return just R's. Which is going to be basically, I guess, R's. So where R's is an iterator where the item is R, but it could be any kind of iterator. And then what I need to do is something like, oops, that's not what I want, is something like this. There's got to be a better way to do this. I don't even know if this is going to end up compiling. We're going to find out, because I'm going to try to do it this way until I find out that I can't. So this is not going to take a wise item and individually process them that way. I'm going to try to... I'm not really buying myself much by doing it this way. It's just that I don't feel like I want to... I want to feel like somebody can put as the tails any iterator that they want that they may have built out of composite stuff. I use iterators as much as I can to produce the values. So this is as lazy as possible, and then I don't have to decide how its next operation works, and nobody has to composite stuff outside or build sublists. So this is what I'm going to do. Subvectors. Okay. But that means that this is f of x's and f of y's. So let's get all the naming conventions sensible. For loose definitions of sensible. All right. That has to change. That has to change. Yeah, exciting. And the only reason, the one thing that this does make simpler is because all of the logic for stepping through stuff is buried in whatever this R's iterator type is. Oh, hang on a second. That's not going to work. That makes no sense because an iterator assumes it's a collection on which it's already that it's already based. I need something where I can map a function over an iterator and then iterate on that, which means I still need the function. Go back to my C# for a second. So what I basically have is I actually produce a tail iterator by applying a function that takes an iterator and so this could be a map operation on another iterator. Is that what I want to do? Is that a sensible thing to do in this style? I think I still want to try it because I want to be able to understand the concept of being able to return, basically adapting iterators as part of a function. Let's see if I can get there. Let's see if I can get there in this fashion. Okay. Having done all of this, what's going to happen is we're going to have a sum of sum of x and sum of y are going to extract from the individual iterators. I'm going to have to do a filter operation at some level here, and because this is not worth doing as a nested function like I did in Haskell, or I can do a post filter. So I'm going to do a filter in here at some point. So this is extracting the individual values, and if not, it basically just ends, and that's a problem. Let me think about this a second. So the thing here is I'm doing pattern matching on calling these, but it's not like I want to stop the entire process if one of these has successfully extracted a value. I think if I do it this way, and I try to process IX and IY after this, because I'm going to have to for the tails, I will have likely consumed one during a call to next that I should not have. These always advance. God, it just, statefulness like this drives me nuts. Okay. Okay. Let's keep fixing up our data types before I get into that. But what I am going to do is I'm basically going to do this. No, I'm going to do I need to be able to return R, so I'm going to just do actually X. Oh, except it has to be option because I have to know when to end. So it's actually going to be sum X. I'm just going to return the first list just so that I can get this compiling. Because what this actually does internally is not going to be nearly as important as getting all the type stuff working. Actually, I don't need to worry about the X's. It's already taken care of. So I need all of that. All of that. And that. And I'm going to grab all of this. I actually have to be able to pass in F2, F of X's, F of Y's. IX's of type X's, IY's of type Y's. Help a local variable with a similar name f of y. I cannot find value iy in the scope. Why is that? Because I should have just called it y's. So there's y's, and x's is going to be self, and f of X's, Y's, I did see I don't need an extra Y's there. I did see an interesting comment reading through piles of Rust documentation over the last little while that the one place where they're starting to think about doing return type deduction is partly to deal with the rather egregious data types that are coming around building up iterators. I think as people do more complex generics wizardry in Rust, that's going to become more and more important. And yeah, I'm sure there's lots of reasons why automatic return type deduction is less desirable. But I mean, Rust already does it on its lambdas. They just don't do it at the top level functions. From what I'm given to understand, I am not an expert in this. That's why I'm fiddling with this on stream, to force myself to learn it while everyone's watching, because apparently pressure makes me do really stupid crap. All right, so let's try to do a build. Sure. Still not used to this editor. Failed to parse manifest. Not sure why it's saying that. Okay, I'll catch that in a second. Compiling, finished, compiling. Oh, because this isn't being cleared is the problem. All right, so problems. This enum. All right, this enum takes 2 generic arguments, but 1 generic argument was supplied. Which one is that? Oh, result. Maybe this isn't the type that I want. Rust optional return type. Option and result. See, option is amongst a set of things, right? I don't really want that. What I really want is basically, I think option is a kind of union, yes, effectively, similar to the variant type in C++. So use options, and it can either hold a sum t. Oh, it is option. So option is not like, I stand corrected. It's not a result I'm after, actually. It's basically, I can hold some t or nothing. So that is where I had made my mistake. All right, this takes 1 generic argument, but 7 have been supplied. What have I done here? We need merge zip withable. Oh. Because actually, merge zip withable, most of the parameters are actually on the function itself. I only actually need self for that. Trait objects without an explicit din are deprecated. Fun! Okay. And the reason for that... except it's not merge zip withable that I'm actually returning, and that's why this had 7 parameters. What I'm actually doing is returning the actual state structure, which is merge zip with. Because actually it should have matched that, right? Because it's the thing I'm trying to implement. So we're down to 1 type annotation needed. Satisfy F2 as Fn once. Okay. So, type annotation needed. Cannot satisfy F2 as Fn once. It's required by this bound in merge zip. It's 53. Okay. This is going to be exciting. So why do I need to satisfy? Oh, because I screwed this up right here. I've got an extra F2 here. It cannot be both. I mean, I don't know if that's actually solved the problem, but it certainly can't be helping. Oh, now we got 7 different problems. Mismatch. At least it's somewhere down in the code here. So, mismatch type. So, in order for this to, okay. Did I not call it X's and Y's? No, I did not. And that's why that is not working here, because I'm using a syntax which requires me to not have to specify the types. No, I've just added more. That's great. That's great. My zip width, etc., has no field named XS. Yes, it kind of really rather does. But what have I screwed up? Oh, because it's not my zip width, it's merge zip width. All right. Yeah, now we're down to 2. No field named IX. Right, because this is going to be X's. I'm going to be rewriting this anyway. And Y's. Okay, down to 1 problem. What are we at? Mismatched type. Why is that then? Because X's... Oh, because I can't guarantee that ours is in fact an X. Okay. Okay. All right. Well, let's pretend for the moment that this is a zip. So I've extracted X and Y. So I'm going to say that let V equal to F2 of X and Y. So it's pulling out each of the individual items, and actually what I need is that I need some X, possible V, some action, possible V, is equal to F2 of X and Y, because what I should be getting back is an action and an optional. But I don't want to break apart what the optional is going to be yet. So why does this not work? This is saying mismatch types. Why is this saying mismatch types? Because F2, not finding a function F2 in scope, because it's actually self.F2. Self.F2 should be takes an X item and a Y item and produces an action and an option R. But that's exactly what we're trying to produce, is an option R. Just gonna actually do a proper build on this. No method named f2 is found in merge zip with. Except it really rather is. It's here. Okay, let's actually take a look at the output of this. What I'd like is a thing to be able to clear the terminal. Can I just go? Yes, I can. Which means when I then go to do a build, that's fine. That is a field and not a method. Right, I had this problem before where I had a function where it was binding the wrong way. The associativity is a little bit funny for functions. I think I have to do this. That's better. So okay. This expression has type mzw step, comma, option R. And expected, because it's not a sum action on this. It's actually just action. Duh. Now I could, yeah, okay, so that's fine. The value here that I want to actually extract, I could do something like, I'm actually half writing this by the time I get this done, actually. The only problem I'm going to have is that it's, I think, going to consume one of these iterators one step further than I really want when one of them runs out, which is a problem. But what we can do, we actually want to produce an expression. So we're going to do a match. And I haven't done a match before, but I think what I want to do... because I don't want to do a daisy chain of if and else's if I can avoid it. Rust match. Nice. So it's an expression. I love expression languages, incidentally. They make me very happy. So what we're going to do is we're going to say match on So what I really want is sort of an optional, I want sort of a, this is going to be interesting. The I need to be able to keep processing in a loop whether or not I found an item. See, again, I'm down to the point of almost solving this just in order to get this to compile, which actually, you know, in a lot of ways is a good thing, because it forces me to... right, okay, so... Bool... kind of want to do something like I want to loop forever, but I want to be able to break out of it at a specified time. This is more or less an infinite loop with an interior break. So I think... what I want is something like... That's going to be an interesting thing. I need to be able to... I need to be able to peek at the head of an iterator. To see if it... do iterators allow the concept of peeking? They don't. They just return a value. They just return the next value that's in the list. But I need to be able to look at those values before advancing. Because I need to be able to say, I need to be able to look at one of them. I need to be able to look at the to see if each of them, to see if they have a next to begin with. And if they do, I can then output something. Optionally output something because of the way I've written this. But if I do not, if I am not told to advance one or the other, then I have to leave them as they were. It's an interesting problem, isn't it? I need to be able to call... I need to be able to know if I have an available value without calling next, but I have to call next. Which means what I kind of need to know... I need to be in a state where I either know I have to call next, or I can avoid calling next because I already have a value from a previous call. I wonder if somebody's actually invented a Rust iterator adapter that does this. Because this seems like something that's going to come up a lot. Because I'm not sure I could implement, for example, a basic merge sort. Unless I could look at one or the other, choose one of them, like the smallest, for example, during the merge operation part of it. I mean, choose the smallest out of the two lists, consume it, and put it in the output, and then call next, but only on that one, and then be able to look at it on the next pass. Like, whereas on the one that I don't advance, I want to be able to refer to its value again. This function doesn't maintain state. And I don't want it to maintain state unless it could maintain state on an instant-by-instant basis. Basically, state that this thing is maintaining is literally up here. So what I think oh god, what I think I actually need is, I guess something like an X, which is an option XS item, and a Y, which is an option XS item, so that serves the dual purpose of, if I have an X or a Y from the last pass that I pulled out that I have not yet done something useful with, then I can use it on the next pass. Like, I can preserve a value that I haven't used. So that can be a none, which means that I am not currently considering an item. Or it has a value which I have previously extracted from a call to next, which means I don't have to call next. This seems like a pattern I would use over and over and over again. And if I can think of a pattern where I would want to peak at an iterator value, in order to logically perform this operation. All right, I'm going to look that up, actually. So there's no point in me doing this if I can just, all right. Rust. Peak at an iterator. Peakable. An iterator with a peak that returns an optional reference to the next element. The struct is created by the peakable method on iterator, etc., etc. And it's in is it by default available? I haven't quite figured out the crate system yet. But there it is. I mean, literally... Yeah, so... I don't like an iterator mechanic where next is the best that they could do. Or is the only thing that they could do. Like, I'd prefer if all iterators were peakable. I'm used to that from C++. I'm used to that from Haskell. I can just look at whatever is at the head of a list acting as an iterator through a collection. And I can... Anyway, it doesn't matter. I guess the advantage here is that for non-peakable iterators... you could use it for streams where you can't peak by default, but then you'd want to be able to make it peakable. So but the struct is created by the peakable method on iterator. All right, check this out. So, God, I got to look through all of the crazy number of methods that are built into your basic any kind of iterator. This madness, fun madness, but madness. So this creates an iterator which can use the peak and peak mute methods to look at the next element without consuming it. See the documentation. Note that the underlying iterator is still advanced when peak or peak mute are called for the first time, which is exactly what I was just about to implement. That's just mental. Okay. Okay, so I'm not going to implement. I'm not going to implement this. What I'm going to do is I have to make sure that peakable is the iterator kind that I'm after. I don't have to necessarily return a peakable iterator, so that's fine. Except that's not found in the scope, so I don't know why. I'm going to have to figure out the crate, I guess, in which this exists. How do I figure this out? Because whatever the structure is, I want to be able to say, or whatever the iterator is, and this is going to be, again, I'm going to, actually the iterators that I'm going to pass, kind of figure this out. The structure has to maintain peakables because that's just what I'm going to be using. Because that's also going to be the, oh, except the functions for f of x's and f of y's. Ugh. X's and Y's are going to have to be I had to conditionally look at these. Because I need it to maintain that optional look-ahead state. Oh, God. Not found in this scope. Can I give the fully qualified name? Function peakable returns a peakable, creates an iterator which it creates an iterator which you can use the peak and peak mute methods. Okay. Peakable new based on self. And this is going to get hairy in a hurry. Okay, this is not helping me. Yeah, I haven't implemented a new function on my merge zip with. That's the sort of the pattern that I see going on here, where the function itself just calls the new operation buried in the structure step by, for example. But let's what I really want is the structure itself. So the iterator for peekable. I think the reason why I didn't implement it that way, partly because I was recommended it by another by a Rustation, somebody who properly codes in this stuff, who walked me through doing it in this pattern because I had to do it as a trait. I couldn't do an impl. So wow. Iterator with a peak that returns an optional reference to the next element. That's fine. This struct is created by the peekable method on iterator. See its documentation for more. So the basic trait iterator, any iterator in principle can have peekable called on it. That's kind of awesome. I keep forgetting iterator isn't sort of a type, it's actually a trait. It could be any category of types. And basically this is just a sort of an adapter that says I can ask an iterator to become peekable. And if it is able to be implemented as a peekable thing, like mine, arguably, so I've created effectively my own I guess I've technically created my own iterator, haven't I? And because I've created my own iterator, I might want to implement, for example, peekable, a way to do peekable. Maybe there's a default implementation, but I wonder what happens if I try to call peekable on mine. I'm supposed to be an iterator. Because the default behavior... Can you have default behavior for a trait? I'll have to look that up. Because the default behavior would be to wrap an iterator around self, which I think is exactly what it's done. All right. I say. I don't want to re-implement. All right, I don't want to re-implement peekable. Okay, so what does this mean? I need to be able to... I need to be able to say that that XS is... How do I say that an iterator is peekable? I mean, I can ask for an iterator that is peekable. But I can't guarantee that it is one. Gotta think about this. Is peekable isn't a trait. It's a struct that wraps around another iterator. That's kind of weird though, because what if I wanted... Oh, and I just realized you probably can't see what I'm actually staring at. My sincerest apologies. I've been looking at this for the last little bit. It is not a trait, so it doesn't belong here. Is there a trait? I've been thinking about this wrong. It's not that you might mark a particular kind of iterator as possibly being peekable or not. Peekable is an adapter, like a wrapper that has to be able to wrap around any kind of iterator. Like there aren't any restrictions as far as I can tell, which means actually what I need to be able to say here is that X's is actually a peekable of X's. I still have that naming problem, but this is now a structure that is wrapped around another iterator, and I know that X's and Y's are iterators, so this is iterator. It could be any iterator, but what I need to be able to do is peekable is a struct. It's a concrete type. Well, so it's a generic type, but wrapping it around an iterator makes it a concrete type. And I suppose, arguably, if you have X's and Y's being an iterator type, it is itself an iterator. I think I'm doing this right. I don't need to worry about this nonsense on these guys because these are going to be handled separately, so let's just ignore those for a moment. So if X's and Y's are the underlying type, then what I'm really, for this function here, we need to have X's item and Y's item is fine. As an iterator adapter, the items are still the same. That's fine. All of this is still fine. I really want to be able to actually put these type annotations sort of before all of these because I'd like to be able to base some of... Anyway. if we're peeking ahead, the problem is we need to be able to pass on whatever the tail is off to. So this is actually going to have to be. A peekable iterator. So an implementation I iterator for peekable I. An iterator doesn't have to be provided with a generic member specifying its type. It's just an associated internal type. Oh, wow. Okay. Ignoring all this code in here because I am still trying to figure out what types I need to manage here. Ultimately, so once we've created one of these things, we know that X's and Y's are actually a sort of a wrapper around an existing iterator. Which is kind of what I'm doing for my, honestly, that's exactly what I'm doing with my merge zip with. I'm just doing an adapter that happens to take two iterators, right? And I'm basing my item, for example, indirectly anyway, on the X's and Y's. I'd like to be able to state this specifically, that what R is really the act of applying, say, f of n, one of F2, an F2 to an element of X and an element of Y, so that I didn't actually have to pass it in specially. But it doesn't matter. The fact that I have to pass it in specially, I already talked about the unification thing earlier on, which happens when I actually have when I actually construct one of these things by way of a function call. That's where the type deduction and unification all gets tied together. So, I think I'm okay with this, because by the time I'm in here, I already have these constructed, which means I already have peekables on this. Which means whenever I do a merge zip, what I really want to do is I want to say, I'm not passing in self, I'm passing in self dot peekable, because whatever the iterator is, it has to be able to supply peekable, or an implementation of peekable, or it has a default that implementation. There we go. That's actually, that wise refers to the structure, that wise refers to the parameter. I think that's how it works in the Haskell version of this kind of structure creation anyway, so I'm going to assume that for the moment. And then these are just left alone because they're just functions, and they just operate on iterators. Except the fields of the structure are omitted for type peekable. Can I get at them? For iterator adapters, is there a common way to state how to get at the underlying iterator type? It's just called iter. If I made the assumption that that was a common pattern for creating a standard iterator, if I'm wrapping it. For a single iterator adapter, that would make sense. For a multiple iterator adapter, what I actually might want to do is actually have... Why am I getting weirdness in my headset? I've got weird audio coming through on my side, which I don't think is audible to you guys, but it is audible to me. So I gotta figure out what... That's just plain weird. Said a couple of... Alright, sorry, I had a weird audio glitch on my side. I'm still having audio weirdness, but I think it's actually on the on my laptop, which I have kept my headphones on for. Okay. I have to sort this out or it's going to drive me nuts. There we go. Don't know what that was all about. Never mind. Carrying on. Code. Sorry, had weirdness going on my laptop, which I'm using separately from my my main desktop device in which I'm doing the coding. Okay, back to work. But not for very much longer, because I do actually have to get some sleep at some point. I'm going to go for another half an hour, I think. So I'm slowly working my way through the way this works. Right. So what I need to do, I don't need to implement Peekable because I've already got that sorted out, I think. At least closer than I was. And since it's Peekable, instead of doing next, what I really want to be able to do is peek. And so the Peekable operation returns me an option as iterator, which means that instead of getting... returns me an option without consuming, but then I have to call next in order to advance it. That's peek and peek mute. Because peek mute returns a reference and many iterators iterate over references, there can be possibly a confusing situation where the return value is a double reference. You can see this example as below. For the moment, I'm not going to try to make this absolutely bulletproof for all types. I'm just going to use, except that peek actually pulls out option I as iterator : item, returns a reference to the next value without advancing the iterator. So like next, if there's a value, it is wrapped in a sum t, but if the iteration is over, none is returned. And that's fine. That's more or less the kind of behavior that I want. It returns a reference, and many iterators iterate over references. It can be possibly confusing. Okay. And I guess I use next to advance it anyway, just like before. It's just that I ignore the return value in that case. All right, so this is going to change the nature of this slightly. So this is actually going to be Iterator does not advance even if we call peak multiple times. Meta iterators iterate over references. I don't think any of the things that I'm doing are iterating over references as such. And if I were, I would want to just pass on the reference because I'm basically adapting one iterator to another. So if I get a reference, I want to treat it as if it were a value. Like I want to treat not the underlying value, but a value in and of itself, a pointer, basically, for all intents and purposes. So thinking about this then, I know that it returns a reference, though, so I have to... Come on. I have to... probably actually do something very similar to this. So let's throw this inside my loop. Let's see if I can turn on, where are the options here? Preferences, settings, text editor, formatting, format on save. I thought I had that on. Well, it's certainly not formatting for me. Well, anybody on my stream? Oh, as far as I know, I'm fairly new to Rust. You don't actually have to implement Peekable. You implement Iterator and you get a Peekable functionality for free thanks to default implementation of Iterator : Peekable. Yes, I actually figured that out. And sorry I didn't actually... Hi, Jeff Erroneous. I don't know if you're still on the stream, but a shout out to you for saying that. In fact, to say implement Peekable feels wrong because it's a struct. Hey, how you doing? Yes, I agree. I know. I hope you don't mind. I stumbled through that on my own until I deduced what was going on, and I came to the conclusion that not only was Peekable an iterator itself, but directly a structure itself. And that I didn't have to do anything special about implementing Peekable for any given kinds of iterators, that it had to have a default implementation. I got there eventually, but thank you so much for pointing that out because I really appreciate it. I am new to this as well, probably way newer than you are. I'm just doing crazy type stuff before covering a lot of earlier bases on the assumption that I can grok most of this because I've done a fair bit of Haskell. But this obviously it's not a one-to-one correspondence, so I stumble over quite a number of things. I actually love the fact that there's the iterators, a lot of the features of these iterators, and I'm loving the type system, but there's still a lot to learn. So anyway, formatting on save might need to be turned on in your Rust extension. You'd think rather than you're saying within the extensions. Oh, good God. No, that's new extensions. It's definitely not what I meant to bring to pop open. Please go away. Yeah, because I thought I had it working, and the formatting thing is just not working for me. So in add-ons, oh, all right. You'll have to give me more help than that. I've only just started to use this thing. Run Go View Selection Preferences. Preferences for extensions. No, again, not what I was after. Do. Can I pull it up here? Probably not. All right, how about... No, that seems like the wrong place to do that. In the sidebar on the left, the icon with 3 squares with a 4th square nearby. 3 squares, oh, that guy. Yeah, okay, so, oh, there we go. Extension settings. Okay. Log to file reveal output channel RLS path, rest of path, lots of path stuff. Rust build on save, that's kind of cool. Oh, only index the project when a file is saved and not unchanged. I can leave it unchanged, that's fine. Clippy references, create blacklist, rest features. Oh, full docs. Is there a search in here? Turn on settings sync. Anyway, Rust analyzer, Rust flags, show hover cut. It's just not super well organized. Targeter, Rust target unstable features. It's not really obvious to me in here, and I thought it used the basic. I thought I had it working at one point, and I clearly don't. A Rust format is a tool, a setting in the extension for Rust format. Okay. Rust analyzer. I was pretty sure I had Rust format on. Like I was pretty sure I had this. I'll open up my VS Code and see what I have set up. Hey, if you find something easily, great. That's fabulous. Don't push yourself on my account. I can always solve this at a later time. But boy, howdy, it would be kind of nice to just get that out of the way, so I don't have to keep fiddling with it. Extensions, Rust. Yeah, RLS should have a built-in Rust format thing, though, as far as I know. To enable formatting on save, you need to set the editor format on save setting to true. Find it under File Preferences Settings. That's basically the way I thought I had set up formatting on save. It's like literally listed in the plugin. But if you find another place that it needs to be, by all means, tell me. I'm just going to take one last check in here. Format. Formatting. Format on save mode controls the save formats on the full file extensions. Only applies when editor format on save is enabled, which it is. Formatter must be available. The file must not be saved after delay, and the editor must not be shutting down. Okay. A formatter must be available, but the Rust thing alone, the Rust programming language RLS thing here. Sorry, this guy should have provided. I wonder if I don't have Rust format installed. That's a good thing. That's an easy thing for me to test. There it is. So it is available on my system. Don't know why it's not using it. Still haven't figured out all the vagaries of VS Code, though, to be frank. It's literally had it set up over the weekend and haven't really touched it more than just being able to build for the sake of the stream. So, boop-a-doop-boop-boo, ba-doop-boop-boo. Where was I going with this? I was going, basically, that if I needed to possibly say some reference X, can't even see straight anymore. Yeah. Come on. I clearly have to get some sleep. Rust. Peekable. Yep. Ampersand X, ampersand Y. Just borrowing for a moment. And we need to do peek and peek. If they are both available without, whoops. If they are both available without consumption, then we can do something with both of them. So what we can do is I need to be able to do output a value based on several different matches. So if we're going to do quickly make this big so I can find the right tab. Need to figure out tab groups or something on this. So what we're going to do is we're going to try to do match of that. I have formatted, save, enable, format on save and set to file. Yes, so do I. I use the Rust Analyzer extension, not the Rust extension. Can't find anything else related to formatting. Okay. I will check out that as an alternative extension. This is the first one I found. Seems to do well. I'm totally... so an alternative Rust language server to the RLS. I will check this out as a possible alternative. Like I said, I thought it was working at one point, and it doesn't seem to be, and I don't know why, but... Oh well. So the result of this is going to be I need to be able to do two things in this loop. I'm not going to get a chance to do a post filter step unless I wrap this inside a further function, which I totally could. That's kind of how I did it in Haskell. I basically had an inner loop which produced what amounts in this to being optional R's, and then I just filtered out the ones that were none as a post process. I kind of want to do this in the one loop here though. So the value of this loop is going to be whatever I use a break with a value. So what I really want to do. Again, probably a million ways to do this, but if sum R, if let sum R is equal to, and then effectively this let, how do I want to process this? Basically, oh, not the way I want to do that. That's too complicated. What I can do instead is say, I think it's break none when I'm breaking out of the loop operation but wanting to return a value. Let me go check that out. Rust, I'm gonna leave that up. Rust loop expression. It doesn't work when you have a compiler error, but you're saying that that's not true. Yeah, it's a weird one, right? So there's predicate loops, predicate pattern loops, using the while lets. I love those. Iterator loops, love those too. Loop labels, which I don't want to deal with, but break expressions. Yeah, this is kind of oh, I see. A break expression is normally associated with the outermost loop. Continue expression, break and loop values. This is actually what I'm after. Let result equal loop, blah, 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 if condition break B. So it's actually, hang on. Okay, so this is what I need to do. I need to do that because this is associated with that match. Hang on. I've done this in a very silly way. There we go. So that break none will return a value saying we are utterly and completely done for, except that's just going to return the value from loop, and that's the problem. What I really need to do is I need to be able to loop yeah, this has to be if let I'm going to have to check. That's really obnoxious. I need this loop in order to be able to keep processing as long as I don't find an outer item, but I don't want it to immediately return a value if there is none until I've also exhausted the smaller loops. Now, for the most part, the situation I'm going to be in is going to be where I'm processing multiple items, I think. 2 long lists. Yeah. Just occasional loud thump in the audio like you're thumping the mic stand. Oh. I wonder if that's, am I accidentally bumping a desk with my knee? Sorry about that. If anybody has been experiencing that over the last little while, it's either that or I'm drumming my fingers on my desk, which occasionally happens, but it's probably me bumping my computer case and or the desk with my knee. I'll try to avoid doing that. Or I'm drinking a cup of coffee, but I'll remember to put the coffee cup down lately. Good call. Don't want to annoy anybody. Or actually, I just realized it might be me just dropping my wrists down on my desk. I'll try to avoid doing that too. I don't have a floating boom mic on some sort of like a vibration, anti-vibration thing. Basically, just have a Blue Yeti sitting on my desk, and the padding is not necessarily the best. I don't know what I can do about that aside from getting like a boom set up, which will take more effort. If I keep doing this, maybe I'll do that. Okay, so here's the thing. The problem is I'm not sitting here sort of doing a continuation style passing thing like I'm doing in C#, where I can just yield a value out of the entire expression, but then the loop continues on next time. This is entirely stateful, which means I have to go into and out of this function entirely. Any state that I manage on the entire function. Not very many Rust programmers on it this time of day. Yeah, not many for me either, because this is actually way after my work period. I usually do this on the weekend, probably 6 hours or 8 hours earlier than this by, but I am trying to learn this as hard as I can, as fast as I can, I guess. I don't know how much effort, how much energy I'm going to have to keep doing it at this pace. But yeah, I want to keep doing it, and I may have to do at least some of this during my weekday because sometimes on weekends just get occupied by other things. And I want to figure this out. I just happen to have bitten off something kind of bigger than I can chew all at once because of all the type shenanigans and completely different loop constructs, slightly different way of doing value returns on expressions. This is threading a very weird needle of C++, C#, and Haskell for me. So, I guess what I have not done is I have not spent a great deal of time dealing with the mutability and borrowing issues in this. I fortunately managed to dodge a lot of that. And the minute that starts rearing its ugly head, I know I'm going to get kicked in the face for it. Like, one of the bigger things that I can see is I'm not completely convinced, for example, that any of the things that I've done in this Rust code are going to be universal for any types of collections, even if those collections themselves contain, for example, references, or do something else. They should work on box types because then the box is the value. But I'm going to get bitten by the differences in the way this thing handles references / pointer-like objects compared to the other languages I know. It's neither explicit like C# and C++, and it's not completely hidden like it is in Haskell, so that is going to bite me. Okay, so back to this. Basically, here's the problem I have. I have the problem that every time I come in here into next, I have to do any logic I can to output a valid resulting value, and I can't maintain state in here because this isn't something where I can yield out of it like a continuation style, like in the C# world. And it's not like in Haskell where I can sort of do that implicitly by when I add something to a list that I'm building on the fly lazily. So all of the state that I have has to get buried in here. And do I have enough state to do that? Well, yes, but it means that every pass, every time I'm lazily evaluating, I'm probably going to have to do something like this. I'm going to do this in a potentially inefficient way and then measure the efficiency at some later time, but what I could probably think about doing is something like match. No, hang on. I want to make sure that I'm at the outset in one of three categories. Either I know I have both values, or I know that all I'm doing is going to... Doesn't really matter if my loop's on the inside or the outside on this one. Except that if I have a whole bunch of empty elements, which I shouldn't, but if I'm having there are the sum to n implementation that I have using this in the other languages do assume that I can emit by way of f2, the function f2, any number of empties that I want in order to not have them fill the field. Because I was intending on dealing with the particular return type I have to process empties anyway. So if I have that in here anyway, I might as well get filtering for free, whether or not it's efficient or not. You're coming from Haskell? Yes, and C++. Like, okay, so you want a quick history. Basically, cut my teeth on C way back in the day, like as my very first language a long time ago. And then moved on to C++ because it seemed like a fun thing to learn. I also did a little bit of Java at about a couple of years after that, mostly for university. So I know a little bit of that, but I haven't been touching that for quite a while now, except for one or two small Android things. And then after that, I was in C++ for a long, long time and didn't touch a lot of other languages. I guess in university I did technically have Prolog, Scheme, and a couple of other smaller languages in there, even less used. But they kind of don't count because I really haven't spent that 100 hours or 1,000 hours or whatever it is to really dig into it. But there was a point at which I wanted to learn something new, and most of the languages that were coming out at about the time I started looking, and I can't remember how long this was ago, let's say a decade ago, probably less than that, all of them were kind of C-like and kind of not super interesting to me. Which is not fair because there is probably some pretty exotic stuff out there, but a lot of the things that I was being introduced to had too much of a C++ or C, it's like C-like, C cousin structure to it, and didn't have things that were terribly interesting to me, and functional programming took my brain, and so I wanted to see what languages I could learn functional programming in because it had not really that much exposure to it over the years. And I didn't fall into Clojure or Scala at the time. I fell into Haskell, and I loved the things it brought to the table. Whether or not it's a language I'd develop anything large in, I'm not sure. But it brought a lot of interesting things to the table, like type classes, which tie very well into traits in this, or largely expression-based functions or blocks, which Rust actually has, or destructuring of return values for multiple return values in other situations, or other kinds of pattern matching, and list comprehensions, slash ranges and the like, which Rust also does things in a, at least if not the same fashion, in some sort of adjacent fashion. So that led me back into Rust when I started looking for yet another thing that was new, because it had the same sort of zero cost abstraction ideology. Whether or not it's actually succeeded is another issue, but which I like from sort of the C and C++ worlds, but some good generics and large and interesting language abstractions, which make coding, I think, more able to be reasoned about. Very strong type systems as well. So that's what led me to Rust, because I want to try it now. So there you go, a little bit of history. Which means that when I chose a project, actually, I was doing the if you weren't here at the beginning of the stream, I was looking at in fact, the very first puzzle in the Code Advent 2020 list of puzzles, which was doing the sum to end thing, where you're like finding two elements in a list that added to another value, and that led ultimately into this as a thought about higher order functions that I don't already see. I thought I would implement this, and I decided to go with something that complicated in the type universe, because I was hoping my experiences in Haskell would help me deal with the type system, and it kind of has, but there's a lot of Rustisms here that I'm not familiar with. So I bypassed things as simple as how do I actually create a new structure value. Totally bypassed all of that, which was a great laugh in our last stream. I couldn't stop laughing for about 15 minutes. How come you're doing all this type stuff and you don't know how to create a struct? Because that wasn't the bit I was interested in, and every language has its own way of creating a struct, and it's totally not interesting to me. Which isn't fair, because actually it's kind of neat. I like the way it built. It's a lot of the syntax involving building data blocks that make it quite tasty and try to reduce boilerplate. Like something from Haskell, for example, which I really like. Create one structure value from another value of the same structure where you want to only change one or two fields. That didn't even surprise me when I saw that in Rust, because Haskell does the same thing, for example. And it's something I really love, because I've had situations like that in C++ where I want to be able to do that, and there's no shorthand for that sort of thing. And I don't think that breaks either the readability of the code or the understanding of what it means. In fact, I think it increases both without sacrificing anything. So, where was I? I was going to do a match on the result of this expression. Okay, what do I need to do? Ultimately, so let me think about this. Ultimately, I need to be able to loop. I can't keep doing this forever. I'm already at 10 o'clock. I'll go a little bit longer because I'm starting to think this through. When I get in here, I want to output exactly one item or stop completely because everything has been exhausted. So in order to do that, I have to essentially have to keep searching for an element. Now I either do one of two things. I have one big loop, and inside my loop I say, is my left hand side good? Is my left hand side have a value? Does my right hand side have a value? If the answer to either one of those is no, then handle them. If at least one of them has a value, if both of them have a value, then I want to pull out of both and then submit it to F2 in order to be able to pull out the blended value. If only one of them has a value, then I want to process that loop independently. But in any case, I still can only output one value during this pass. Now, because I've chosen let me think about this, because I've chosen to basically have something which returns an entire iterator out of f of x for the tails. I don't need to do my one at a time processing. I don't need to. What's the best way to say this? I can just iterate on this until it's done. No, that's not even the best way to say this. I can grab one value out of this, and if it is none, I'm done. And if it's not none, if it's some x, then I just output x. There cannot be in this function intermediate nones. And the only reason I'm doing it that way is I kind of did it that way in my C# version. The C++ version processed these elements one at a time. I don't know why I did that. I think it's because I didn't want whoever implemented this to have to implement an iterator for what is essentially have I made my life more difficult here? I don't have the yield return that I have in C#, which made that easy. I'm going to just for can you explain to me binary counting? Oh, well, yes, it's trying to create bigger numbers out of smaller numbers when you only have two fingers. 0, 1. Those are the labels on your fingers. Actually, that's a terrible way to describe it. I mean, it's not totally out of the case, but basically, instead of having a tens and a hundreds column and a thousands column when you're writing out your numbers, you only have a twos column. Well, I guess you'd have a ones column, tens, hundreds, and thousands in digital counting. And in binary counting, you have a 1, 2s, 4s, 8s, and 16s. It's just powers of 2 instead of powers of 10. So every time you get up to a maximum of 1, if you have to, in any column, if you have to add 1 to it, you're basically rolling over. It's like going from 9 to 0, except you're going from 1 to 0 and then carrying a 1 further up the chain. That's all binary counting is. There you go. There's my 2-second suggestion. Ravi, is learning C++ helpful to know how computers work? That's a good question. My answer to that would be, it depends at what level you want to understand how computers work. If you want to say, can I learn to structure my planning of how to do computations in a way that is understandable to computers, I would argue that a language like that is actually potentially a way to understand the way to reason about problem solving with them. But if you actually want to understand the software side that sits just above the hardware, like what the computer's actually processing, you kind of have to get down to assembly language. It's more accurate. You have one finger pointing or not. Yes, that's actually a better way to do that because you can count on binary on your hand doing that. I actually agree, but yeah. I was trying to get down to the fact that that in base 10 you have 10 fingers, so in base 2 you have 2. I'm not saying you have an on and off on each finger. I'm saying that you basically have a... anyway, it doesn't matter. And Frank Mandy says... Franz Mandy... and Franz Mond... I'm sorry, I'm completely mangling your name because I'm tired. All right, anyway, let's stop talking about fingers and binary counting. Anyway, yes, I like C++ for its actually if you want to get to that level, you might as well start learning C, because it takes out some of the object-oriented goo and templating goo that has made C++. I'm gonna say a bad language. It's a very complicated one to get right the first time. If you have a good teacher, it doesn't really matter what one you use. Okay. I am trying to get my brain back into this, and I don't have that long because it is 10 o'clock p.m. and counting at my end. And I kind of want to put this to bed eventually, but I am slowly zeroing in on what I want to say here. And I think I've kind of done this in a silly way because I don't have the yield return type continuation mechanism in this. I can't do the C# version of this quite as easy as I would like. I have to treat this entire thing as a stateless function. Except for the state that I stash up here, but I don't want to implement a continuation style thing with extra parameters up in here because this is already getting kind of icky. So, what I'm going to say is, right, match you know what? Let's it's actually closer to the Haskell version the way I'm going to do this now that I come to think of it. So match none. No, sorry, match against. That's not what I want to say. I actually want to say the result of this. Match on this. And what I need to be able to do, there's a way to do pattern matching that captures the value of the matches, which I will have to look up in a second. But basically, I want to do match on this, and if it happens to be none, then the result is none. We are actually completely done. This is the only case in which this is necessarily true. Right. Too many darn tabs open. Right, and then the underscore for generic match, but basically, and I don't need any guards in here. So there's that and that. Then there is the alternative case where we have some, and it's a reference here rather than a value because I'm doing this this peekable. But this is where we have a sum and a none. And in this case, what we want to do is we want to return self.xs. Actually, no, we want, I want to, hang on, I need to create, I actually want to capture the value that got matched here, rather than having to recall it. Although I do have to advance it anyway, so in this case I don't need to do that because it wouldn't help. I have to call next anyway. So that's that. The other condition is where I have this. And I need a comma up in this section here. That is going to be self.wise. So actually this, in its entirety, handles the cases where, except that's not quite true. It's not self.access.next. It's actually, oh, darn. I don't have an iterator on, this is not a good way to do this, because I was going to actually say, all right, given the, I was going to switch to a state where I was going to process the x's and the y's using an entire other iterator. And I can't during the next operation. If I want to stash those iterators, I don't have those extra iterators. I only have the functions that generate those iterators. So this is a terrible way to implement this for this, because I can't just append one iterator onto the other, and I can't sit here in a loop with a yield. I would actually have to store extra parameters to store the iterators in here. So I'm going to not do this. This was a bad design decision. So I am going to use a hybrid of my C++ and Haskell solutions. Or C++ and, yeah, probably my C++ and Haskell solutions. So this is only going to do an f of x. It's only going to do an f of y. So I got to go and edit a bunch of crap. I hate that. Oh well. Don't need the iterator r's anymore. This is no longer outputting r's. This is outputting actually the same thing as this. Oh, except I was going to use a bool instead of a step, because I don't want to give the user an opportunity to give back a return value that has no meaning. Because basically I expect the person who outputs this to say, I don't need to say left or right. These are not valid when I only have one list to process, because that's an indication of, in the F2 function call, whether or not I should advance the left or the right stream. So I don't want these to be MZW steps. I want them to just be bools to indicate whether or not we're done, basically. So, because one of my conditions for making this is make it really hard for the user to screw this up, the user of my higher order functions. I still have to have an option R for the same reason that if I'm doing filtering at all, I still want to do filtering on the tails. Since I've decided to do filtering in place for the sake of this return value, that's just the way it goes. So, yeah. I had to work my way into finding out that I was making a mistake here, So going back down to here, we don't need R's. Did I leave R's in up here anywhere? Yes, I did. Don't need R's. Do need auto formatting. Darn thing. Just an interesting comment that was made earlier that there aren't that many Rust programmers streaming at this hour. And that is a little bit odd to me, because I would expect, I mean, there have to be people interested in doing coding after hours. There's no reason to exclude Rust in particular. And so it's kind of odd to me that either it would apply to every language or it shouldn't apply to any of them, but I don't know. maybe most of the people who use Rust are streaming in the daytime hours from the other side of the world. I don't even know what I'm saying anymore. I'm starting to get loopy. So it's a function on y. God, I changed so much under the assumption I was going to go that route. That was so dumb. Yeah, that's fine. Come on. I need to shore this up. This gets cloned over to here. Where you could use search and replace for your fx's and fy's with exact match. You're actually right, I could. I'm being very, very foolish. I'm doing this all by hand. It makes me have to think less. Except that I'm going to find bugs all over the place. Yes, I know. Again, I'm shooting myself in the foot. You are absolutely correct. All right. So let's get rid of this for a moment. Mismatched types. Right, because this can't be this. This actually has to be, this is where I was actually going with this. This has to be self dot fx. And actually that has to be wrapped because of the weird precedence they have. Self.fx. There we go. That's what I need. Then self.fy of this produces a similar value, and those now should correspond to the correct types, but let's just double check this. That should produce that is not going to work, and the reason for that is it still could itself produce a none. So what this is going to do is what I really want to do is keep calling this until it matches, as long as I don't hit. I want to keep looping as long as there's a none, and then take the last one. So this actually needs to be a loop because this is the wrong type. Because I need to be able to crappity crap. All right. This is there is a Rust streamer who's usually on in an hour or so. Yeah, all right. There you go then. I need to be able to do a loop in here. What I really need to do is effectively rip through this, filtering out all the nuns, but I have to do it element by element. I can't just pass off an entire iterator. So, what's the best way of expressing this? I need to say something like something like I can do a I kind of need to break this apart one level to find out whether or not I have any elements left. Yeah, so I'm from the USA West Side, actually. Hey, hi from Seattle. How you doing? Yeah, no worries. There's got to be a million ways to do this, and I don't know the best way to do this, but if I do a while let, so it'll be while let some, this is for I'm going to call it an action and a value, while some AV equals self.ax.next. Oh, I need what? No, hang on. While, why is this not allowed here? While, can I not do a while let? While some AV, while let some AV is equal to etc. etc. Do a thing, and then and this is going to be for the bool and option R version of this. So basically what we want is if let, doing this all in one line, which is terrible, but if let some action and kind of a compound version of this, actually. I need, if it's a, I have to do a couple different things though, because I'm allowing either true or false on the first one, and then I have to do filtering on the second one. Because I need to know whether or not that bool is there basically as a halt early. That's its primary operation there, and that's basically to mimic the halt operation in the more complicated expression. So and actually that's a problem, isn't it? Because if I do a while let and it fails, what's the result of that? I may not be able to actually do that. Predicate loops. Loop labels, break expressions, break and loop values. When associated with a loop, a break expression would be used to return a value. So I can't do that with a while. Right. So scratch that for a second. We're going to have a loop we're going to use the break and loop value expression stuff again, I think, because I want to be able to produce. I want to be able to turn this into extract a value out of the loop, and I can't do that with the while let syntax, I don't think, because a while let syntax that stops has failed to find a match, but that doesn't allow you to produce any particular kind of value. If I do if let, or actually I can do it, okay, you know what? Let's do this. Let's do this. Let us do this. Match on X. Come on. Silly formatting. If X happens to be, and I'm going to quickly pop over onto the C++ side of things to see if I got this the right way around. I'm gonna drop off. It's nice to have met you. Good luck. Take care, and hope to catch you next time. Yes, I will probably be on a couple of times this week. I don't know how often, but you know, look for me around this last couple hours worth of time. Yeah, it's been nice seeing you. Thanks anybody who's staying here. Great, and thanks for stopping by. For those who have to vanish, it's been fun. And I won't be doing this much longer either. I will not complete this evening, but I would like to think I could get one of these loops sorted out if I can. And the C++ version of this, the logic I had is whether or not it should continue. So a true means keep going effectively. Yeah. So just by convention, I should have made this a label instead of making it a Boolean. But again, to maintain compatibility. So if it's a false and I get anything else, then the result of this is a none. Oh, and actually that's only going to get me a value. I actually want to do a break. So can I use a match as a statement instead? Yes, I can. It doesn't need to be a value, so I can actually, I should be able to go break. None. But that's not going to work, is it? It says, while matching the match arm starts here, this is not surrounded by a body. Match arm body without braces. Oh, because it needs to be code. Needs to be a block. There we go. So that break, none, is only allowable for loops. So this outermost loop is what will receive the value of that, should that be the thing that's found. Because if we get that, that means an early just halt. If we get true, and we get some, and we get none, then do nothing. And actually, no, we can basically revert that to the last one. We can say if we get anything, anything else will do nothing. And instead, what we'll do is we'll say if we get some value v or r, I guess, then we're actually going to break r. So using match in this case as a statement rather than a value, we're going to send back out of this loop a none if we get false for an early stop. If we get true and it's some r, then we just immediately return that. But what we could get is something where it's true and nothing. And in that case, what we want to do is do nothing, because then we'll go back through this loop and eventually we will exhaust the iterator except I need to be able to let me think about this a minute. Nope, that's not what I want to do. Because X here, yeah, this is just the X's. It's not break R, it's break self. No, I've already done the self X of S. Is Rust the new go-to language to write exploits? Darned if I know, and I wouldn't tell anybody if I knew. Sorry. If I have any kind of value in the peak, then I actually want to loop. I want to actually. What I want to do is I want to. Say x.next. No, not x.next. What the heck am I talking about? Self.xs.next. No, I don't. I don't. What I actually want to do is I want to evaluate what the x's are, or what x is, in order to be able to see if I can go any further. And if I can't, what I really want to do here is I want to say, in this scope, let x equal, no. I need to be able to do the same operation as I did when I'm doing this, so I need to let ugh. I need to alter what x refers to. Scan methods are slow in figuring out codes written in Rust and some newer gen languages. I don't care. Good for you. So I've introduced. I need to be able to alter what x points to from loop to loop. I hate mutation. I've gotten out of the habit of doing mutation. Okay. Rust mutation. Variables immutability. Thank you. Right, so I can rebind what x is referring to. So I'm hoping I can then do, because x is introducing can assign twice to an immutable variable. So I need to be able to say if I actually tried to do this, it's probably going to whine at me. X is equal to I need to be able to advance XS, and actually, so X is equal to I don't need to do that. I need to go self.xs.next. Oh, no, wait a minute. I should be able to go, can I do sum ampersand x? Except is that just because that's in their code block, it's just going to create a an XS that nothing is being done, or an X that nothing is being done with. Maybe not, because it's not a let pattern match. Okie dokie. For the moment, I'm actually going to have this produce none as well, in the hopes that I can get some compiler help on this one. Well, XS itself is already mutable, I think, by definition of being an iterator, but maybe X has to be mutable? You might be correct. All right. Destructuring assignments are unstable. Cannot assign to this expression. Of course. And I've got an RS left in here somewhere. Yes, I do. Yeah. Yeah. On line 25, what do I have on line 25? Oh no, that's an old error. Hang on a second. Let's remember RS is never used. Where is that? Oh, that's up here. Yeah, destructuring is unstable. This has extra parameters I've got to deal with. I don't have R's. Problems, lots of problems. Mismatched types, probably. Oh, this is going to be so exciting. Well, yeah, it's going to be mismatched types because I haven't properly gotten the types out of this. All right. Destructuring assignments are unstable, invalid left-hand side of assignment. Of course. Right. So I've destructured with reference. The thing is, I don't want to make it a reference to a mutable thing. Yeah. Now, this is the point at which I'm going to start having problems with a combination of lifetimes, mutability, and yeah, this is going to be fun. Yeah, I might need 2 lines. I might need 2 lines because I could probably... See, the thing is, the next pass through this... See, this was introduced effectively, I'm guessing, outside the loop. That's fine. I don't care that it's outside the loop. But the thing is X is bound effectively as a reference to an underlying thing. But I can't point it at something... Effectively point it at something new. Not what I want to do because nobody can see what I'm doing. Here we go. So Rust point reference at a new value, which I probably can't do. I wouldn't expect to be able to do it. So I'm not going to try. What I'm going to do is just rebind this. So this is just being done for a test. In fact, I technically don't even need this X in here. So I'm going to see if I can shadow it by basically saying let sum of ampersand X. Okay, so here's the thing. I know I have a value in there, at least one value. So at this point, I should be able to let sum X, just like in my other versions of loop, equal self.xs.next. Right? And every time through the loop, this is just going to be each one in succession. And what I do on this, so this is, so no quick fixes, mismatch types. That's fine, I don't care about that. So give me a second here. So if that's true, I'm no longer referring to this outer X and I don't care. I'm now referring to this one and I'm just continually pulling these out one by one. Except that if the, okay, so let me think about this. If I break out of here and I'm either ending the loop, in which case I don't need to worry about the next operation advancing, or I am consuming that X regardless, because it's either an empty element that I ignore or it's something I return a value from. So this is fine. So what this means is that match X on this thing, and the otherwise case is basically to do nothing, because I'm not breaking with a none. So mismatch types. Okay, so I still have to think this through here. The pair of values, so each of these values is going to basically be an option. It's going to be an option X, basically. Right, it's not break R, it's break. No, actually I am. I'm literally returning the R in question because I need to know each of the X's in this matched list, each of the X's inside the sum unwrap to avoid having to do yeah, possibly. And actually that's a good point. I haven't learned to use unwrap as efficiently as I wanted to, as I should have. So I'm going to do it the long way and then see if I can apply an unwrap to it after the fact. I just need to get my types to match up. And so here we go, the while offspring. Basically, the ultimate operation is a higher order function. There's a version of zip that processes its lists at different rates. And right now I'm handling the much simpler case of what happens when I only have values in one of the lists. So, again, going back to this, the peak operation is giving me an optional on the thing that's being contained. The thing that's being contained is going to be it's actually going to be an X. Hang on a second, let me think about this. So let sum X equals self. No, this is not right. This is not right. This is because the type of this is wrong. The type of this this function call is wrong. It's not that I want an X value. I actually want self dot f of X as applied to that value. Because that's going to get out for me. a bool option R wrapped. Oh no, that's not going to work either because that peak is going to be a. No, that's fine because the next function. Oh, hold the phone. The next function returns a reference to a mutable item. Is that going to hose me? It's actually going to return an option again. Oh, isn't that interesting? If I have a peekable iterator going in here, then it's always going to return an option. Okay. There we go. Okay, that's fine. So this is the thing. This, because I've done the peek, this next must be able to return a value. So this is where I should be able to do an unwrap. Hasn't solved my problems, but I think that's correct. So hang on a second. What are you doing here? Next returns an option or of whatever the item is because none means the end of the list. Of course it does. I'm smart like a sack of hammers. Thank you. I've been doing this for too long this evening. But that being said, I've done the peek, so I know it has to work. But that's not true every time through the list, actually. Okay, so this let may not succeed. Okay. And in any case, I didn't need to do the unwrap and that. So hang on a second. I got to think this through again. I'm in a situation where I know that the value being returned by peaks in an optional, and I know that in fact there is at least one in the first part of the list, and there's none in the other list. So the second is an empty list. The first has at least one element in it, and at this point, I want to walk through the list, making some judgment calls. So at this point, I can do this. Because, no, I can't do that. I actually have to have, let some x equals that, and then I have to call, so actually this is some optional x equals blah, 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 and I'm being really, really dumb here because I have to deal. I've done this really, really silly fashion. All right. Let x equal the next value to come out. Match on x. The point at which we absolutely know we have no values. One of the ways in which we do this is where we have none. At which point we're just going to, actually that last case is going to catch it anyway. If we have sum of a tuple that contains false in anything, then we break out with a none. And if we have a sum which contains a true and a value in a tuple, then we want to break with the application of self.f of x on r because r is the actual value, I think. Now what have I screwed up? Because we have mismatch types. That's fine. From here we have break none as well because that should catch the still got an error here. Do you know about the question mark syntax thing where effectively you can, it's basically the Rust equivalent of an error monad, and I don't know how to use it very well, no. And I certainly don't know how to use it deep in nested contexts like this. But I do know it's used in situations where you want to basically, it's not applicable here if you have to peek. Yeah, possibly. Yeah, I'm going to try to find ways to refine this after I get it working in a semi-reasonable way, and one of which is starting to use more advanced syntax like that. But you make a good point. I have to basically conditionally test one or the other, and the failure of one doesn't necessarily mean an immediate return of a value. It may mean that the other one still has values. Maybe not in this inner loop, though. So this is going to get an optional. This is going to get an optional value that contains an x. Oh, hang on. I am being thick. I am being thick. Scrap all this. Scrap all this. Think about this a second. This is an optional of x. I'm going to say that match x on match optional of x on some okay, there's going to be some x, and then there's going to be anything else, none. And actually, just to see whether or not I'm in completely bogus territory here, what if I return none from both? This is actually supposed to be sum of O of x, optional x. Mismatch types again. Let whatever equals self.xs.next question mark. Yes, it kind of is. Hush you. Probably. Sum of something leads to none. Match on OX. Yes, because this is an optional x, and if it happens to be, then I just want to return none, but it's for some reason telling you the types are not correct. Because this is actually supposed to be a break none out of the outer loop, like I had before. This is a statement. Still doing something silly here. Sorry, the bool. The bool is a mechanism by which I can return a valid value from the function, like for an existing value of x, for an existing value being pulled out of the source iterator. It comes back as none, so it's something. It's a value. I then pass it into my function. That function is allowed to say, actually halt early. This is where I'm deciding I'm done. So it's just a way to early stop those, because I have an early stop on the pairs, so I wanted to have an early stop on the tails as well. That's all that's there for. But right now, my big thing is the outermost, like the actual iterator. If the iterator runs out, then basically I want to break out of this loop with a value that's none, because that should be the resulting value. It won't happen on the first iteration of the loop because we know we have at least one item, but it may happen on subsequent editions of this. What I really want to do right now, though, is just get it to return similar values, and I'm not sure why I'm not able to do this unless I'm not allowed to have a break none clause to break out of this loop from within a match, which would seem a bit silly. I'm getting closer. I am getting closer. But if I can't make this work, I'm not sure what I can do here. Rust match statement. quite the version of it. We want the match control flow operator. It does have to produce a value, even though it can have side effects. But the value of a brace operation should be unit. I would have thought. May not need the colon there. Hopefully everybody can see. I probably made that a bit wide. Let me see if I can shrink that up for everybody. This is the kind of thing I'm seeing here. So you can have side effects within arbitrary code. The code has to evaluate to something. Put the break in front of the match. In front of the... I'm not entirely sure what you mean. Oh, like... Not sure that's what I'm after. Like, all of the match examples show that the match actually has a value that is a part of it. It's actually a match expression, but that expression can involve the execution of arbitrary stuff. I'm starting to think that I can't do a break from within a match like this. Yeah, that would only work if all the matches are going to break, and not all of them are, right? So that's sort of the thing. I wanted to basically have this loop be down to wherever that is, down to here, I guess, to be an expression that is the result of this outer match that gets the ball rolling. But I'm not sure I can do a break out of this outer loop from inside the match, which is a bit of a shame. Or if I can, I'm not getting some type right with regards to, like, if I had this, but it's still not liking that. It's because the loop isn't in brackets. It should be. There's one bracket, there's the other bracket. Oh, you thinking because this isn't in brackets. I shouldn't need a bracket as long as the expression is entirely a value. You can see examples of that, for example, on the right-hand side here. You can literally do, you know, match of something, turn a none into a none, turn a sum into a sum. These are all values. Turn something into a number. And actually, even individual statements don't need to have it. It would only be if I needed to have a semicolon thing in here somewhere. You need to do something like break none none. You think? No, I don't. And the reason why is because this produces a none. Like, this produces effectively an optional t for whatever t is. It's actually optional r. This should be optional r here. This should produce optional r. And that includes that entire loop expression. And I'm seeing in the examples here that effectively, if it's a single statement, even if it's a macroized statement, it looks like I still need that comma afterward. Except maybe not here. Curly brackets typically aren't used if the match arm code is short and listing 6.3 where each arm just returns a value. If you want to run multiple lines of code in a match arm, you can use curly brackets. That totally makes sense for me. I think the problem is I think the problem is I can't do a break value call from within here. It's basically something that has to be done as a statement within the loop. If anybody can figure out how to do a break within a match like this, let me know. But means I have to rethink this a little bit. Yeah, I could do an if-let. I could probably do... specifically, I could do an if-let that involves a... yeah. Yeah, but you know, an if-let can still... No, an if-let can't do a value. That's actually not true. If you do an if-let, the act of it not pattern matching, it has to stop execution of code and just go on past it like an if, but it doesn't itself contain a value. Whereas a match is specifically producing a value every time. It has to produce a value every time, even if there happen to be side effects on the way to getting there, like in this example. I hate side effects. I got so used to not doing them in Haskell, and now I have to... Anyway, blah, 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 blah. Okay, so, yeah, so you make a good point. So I might have to do something like, and I got to find a more compact way of doing this, but if... yeah, this is going to be interesting. All right. Let sum of anything equals x. Then we're going to do this. This is basically a break none. No, this is actually where I have a value. But it doesn't matter. Let's do a break none for now, and let's just see if we can make that work. Can this even compile? This is saying mismatch types again. Why? Why? Equals OX. Yes, because you need to loop until there is some. Yeah, I do need to loop until there's some, but no. So the actually, the first thing I'm testing, okay. So I got to be careful here. The first thing I'm testing is to see whether or not there's actually any remaining elements in XS. So that now for the first loop, it's always going to be true that there's some, but on subsequent loops, that's not necessarily going to be true. So I have to treat it as if it's some arbitrary loop. So this may do an extra test, which actually, now that I think of it, isn't fantastic. But that's the way it is. So, at least until I figure out a better way to do this. So the problem is that this if-let is not liking me. Mismatch types. Well, okay. If I arbitrarily said, 0 here, because the thing that I'm returning is a value from the loop. This is expecting an expression. I need to yield the thing that is compatible. No, because that would just make the loop an incompatible statement, wouldn't it? Oh, God, I don't even know what I'm saying anymore. Okay. Can I not just break none, please? Let's actually force a build and see what actually happens when I get the full error conditions. Non-exhaustive patterns cannot move out of a shared reference. Unused variable x and y. That's for that case down there. Don't care. This is... Okay, so I did a build, and it actually did a better break none without the semicolon. I don't think so. It's not complaining about that anymore. No, I think I just needed to force a build so that it worked through all the code again. Because I'm not getting that same error anymore. So, actually, given that, okay, check that action out. I have been fighting with this, and it turns out that that VS Code isn't building stuff. Let's get rid of the 1 and 2. Oops, except I still think I need a break none because it's a statement. It's not a... Yep, check this out. The errors are not where we thought they were. This is actually fine code. So the thing is if there actually is a value here, I don't want to break none. What I actually want to do then is I want to match on. So this is actually going to be sum of x. We're going to match on self dot f of x called on x and what we're going to do is then we're going to have the further cases of false anything yielding break none in brackets. Always remember to do a full compile. I'm no longer trusting this thing to auto detect my errors. I think it's just if we get true and we get a result R, then we want to break on sorry, it's going to actually be true and we're matching on sum of R because it's an option of R. Then we want to break on R. And finally, if it's anything else, because it could be that this has come back with actually there is nothing else. That's now exhaustive. Can it come back with a none? Yes, you're right. It can come back with a none. I'm a dummy. But in that, you're absolutely right. So then it's going to be an underscore arrow, and I'm going to line these up a little bit to make them easier to read, but this is going to do nothing. Because in that case, we come back with a value to say, keep going, but we have to process a value which we're doing filtering on. No method named f of x because I put the bracketing in the wrong spot. Mismatch types. That's fine. We're getting closer though. Here we go. This type parameter, sum does not match with expected parameter x's found associated. Yeah, so we don't have a function on x's. We have a function on x's : item. We are getting closer, people. We are getting closer. I'm now doing these one at a time, so I'm no longer processing entire lists. Which means that all of my examples here need to be touched up. That was a holdover from when I converted from processing an entire list to just processing individual items. All right. Okay. My brain's starting to short circuit. How about yours? Oh, because I have to return an option of the item. And I have done here, but I have not done here, so that I'm returning a none to indicate into the list. But what I have to do, just for the sake of the iterator and nothing to do with my own types, I have to do that, I think. I got rid of the error on that line. There's the next problem. Non-exhaustive patterns. This is actually getting productive because actually that's true. I have the none none, I have the sum none case, I have the none sum case, and then I don't have the corresponding sum case, right? That is the fourth case, which I will now add here. So we're going to have it produce none as well. So that's some x and some y. I have to have a comma to make that happen. Cannot move out of a shared reference. Unused x, y. So some x is actually not being done here. So I could actually go sum of don't give a crap. And I could do sum of don't give a crap here either. Because that's actually going to be the parallel case. And I actually can do the same thing here because all this outer switch is really doing is putting me in one of the three cases. This is not going to work either, and I suddenly realize why. Because if I iterate through all of my x's and y's, I still, in the end, if I iterate through my x's and y's as pairs and I get to the end of one of them, I still want to process the remaining of them using the other scheme. So I actually want to migrate my let logic, my loop logic, out of this entire thing so that it just processes each case one by one, constantly testing. Hang on. Let me just finish off doing this. But this is actually... Variant is never constructed. That's true. I don't care about the never constructeds because I'll eventually use all of them. Field is never used F2. That's true. I'm not using that. I'm not using it FY. So you know what we have here, people? We have compiling code because all of this stuff. I don't need where I did the underscores. I don't need the x's and y's because I'm retesting inside the loop. But the problem here actually is I need to migrate this loop outside for that reason that I just said. And the reason for that is that I do want to test the paired case each time. But when that runs out, I then want to continue trying to test on the individual lists and process those with a second function. So in fact, the y's case is going to look identical to this. And I think it'll probably work just fine. So the individual list cases is fine. And I can probably then write something fairly simple, but then I have to process all of the individual step cases instead of just the Boolean true false. Not a big deal. I think I can do that too. But I got to rework where the loop is. And I'm definitely not doing any of that this evening. However, this bit of code inside this loop is definitely going to be preserved when we next pick this up, because this is the logic that basically processes the single loop case and tries to find an element that it can shove out the door. So, yeah. I finally got all my nones and sums worked out. And you can do a break out of a match. The value that this returns is going to be unit, because it doesn't return a value. But that unit or void or or whatever is just thrown away, and the only thing that happens is a side effect, I think, which should break us out of this outer loop. Whew. Okay. Okay. I can't believe. No idea if this is going to run. It could crash hideously. But I'll get there. This isn't going to be really any shorter than the C++ version or the C# version. Mostly because I had to do this in this sort of stateless loop fashion. But the funny thing is that I should have recognized, I think, that the loop was going to have to be on the outside. Because, and I'll tell you why. It's going to be the last thing I comment on before I go. I'm going to turn on my programmer's notepad for this bit. In the Haskell version of this, you can actually see that the step operation here, this is the internal function. All the filtering occurs outside. So I handle right here. I take out all the maybes, which are the nones, effectively. I take out all the nones with this one line here after I have constructed the list lazily. So just pretend this is a lazy operation, or that the laziness and strictness doesn't matter. But basically, the reason I should have noticed that in the first place is I do my testing for empty list first, empty list second, second and first here. And this is the case where I have elements for both, which I haven't even done yet in the code. I've basically done the equivalent of this. Oops. And so you'll notice that as the tail recursion part of this, that I basically go right back up to the top. It's recursive right to the top here, which means that I'm constantly, each time through the loop that is implicit in this tail recursion, going back to testing against the nulls so that I can handle the single list cases. And that's not what I'm doing right now in the Rust code. Right. Where's notepad off? Right here. The loop should be at the very top. And since I can't do this in recursive form because Rust doesn't have tail recursion elimination yet, but that's fine. I wouldn't want to do it that way necessarily in this case anyway. I do love myself a good recursive function, but sorry, I keep thumping the table. That is me. That has to be me. Okay. So, next time round, when I come back to this, when I can squeeze a day or a night out of my week, because I have to call it soon here, I'm going to move the loop to the outside so that I keep reevaluating the other cases. Which should actually in some ways make this easier because I can just do the pulling out of the OX once at the top of the loop. The rest of this code should remain the same. I'll have some duplication of this code for the other case, except for the Y's. And then we get to the fun stuff. I'm getting there. I'm getting there. All right. Nice following you through that. Oh, yeah. I'm glad. Yeah. It's very close. Like, it's very close. And the funny thing is, I'm really glad I did the set of languages I did, because the Haskell code is very terse, but it has some advantages in the fact that it uses its own lists as its iterator mechanism for the kinds of stuff I'm doing. So it's really easy to manipulate data sets that way, recursively building up lists from the list. Iterators are trivial for lists. Which are how iterators behave, effectively. And except that Rust bears a lot of resemblance to the way iterators are handled in C#. So there's a lot of overlap with the work I've done there with the link version. But Rust is both strict, fairly type safe, and trying to be a sort of a systems language like C++ is, and has some comparable, although not identical, generics. Yeah, there's a lot of ways in which they differ, and I'm not going to go into it because I don't know Rust well enough to make the comparison. But it's a good collection of languages. This language is, for me, steering a real narrow but still fuzzy line between all three of them. So it's been fun. Anyway, the main similarity is the trait interface thing. Actually, for me, I don't find them so much similar to. They're a little bit similar. I kind of agree with interfaces. They resemble Haskell type classes almost to a T. Easily, Rust has borrowed a lot from that universe, or from their common universe. I'm not going to say it necessarily comes from Haskell, but because the thing I don't really have a problem with is the way sort of types look to me. The layering to which they're put to in Rust is kind of scary, but yeah, it's a lot more powerful than interfaces. I just mean the main similarity. Oh, with C#. Yes, but I'll tell you why I saw the similarity in a different vein. That's a good comment. The reason I saw the similarity is C#'s iterators still require you to build an iterator out of a collection, do a bunch of stuff with daisy chaining with the iterators that sort of change underlying contained elements as you go, the implicit associated item type in Rust, and then at the end require you to reify it back into a collection if you need it in a collection. Like, its laziness only lasts as long as it's left in iterator form. And C++'s ranges in C++ 20 are going to behave very much the same way. They clearly saw the advantage of doing that in C# and other languages and said, I'm going to have myself a piece of that. So C++ is going to be, at least a little bit, moving away from their paired iterator idiom to something like the lazy iterators that C# and Rust currently use. Haskells don't behave that way, which is why, although Rust and Haskell share a lot of stuff, their iterator mechanism, they do not. So, yeah. Yeah, okay. I got to shut this down. I'm going to be talking all evening because now I'm starting to actually geek out all over again, except if I had that much geek energy, I would go straight back into coding, which I absolutely cannot do on a weeknight. So, hey everyone, I'm going to call the stream here. Please feel free to stop by again. You don't need to necessarily say hi. Happy if you do. I'll try to talk as much as I can. Sometimes I stream game stuff, which you're more than welcome to join me in or not. But lately it's been coding stuff. I hope people return when I have to be on. I don't have a specific schedule, but nevertheless, I've loved having you all here. Thank you so much for sharing my stream with me, and hopefully I will see you in the next stream.